Hi, welcome back. Today's clean code second part. This code performs several tasks based on the type of the data frames, which is pandas or Spark. There are five steps. First is I'm going to identify data frames type. Is this panda or Spark data frame? Second step, if pandas data frame, I have to clean and aggregate safely. The third step is if Spark data frame, you can use the Spark aggregation then convert to pandas. The step 4 is plots. And the step 5 is save the DFS file store so accessible later. First is I'm going to identify data frames type. I'm going to use data frames object db with columns that we have used. This code checks whether data frames with the columns is pandas or Spark data frames. It tries to display the first few rows. It is the pass. After that, I can print it to identify the data frames type, which is pandas frame or Spark frame. This is class object is PySpark data frames object. So I'm going to try and accept the statements in this time. So I'm going to display data frames object is held. If it is the pandas, we have to use the head functions. Otherwise, except do not use the display method. I just use the functions that shows 3. It is used to when there is a Spark clicked to display. We use the PySpark data frame classes object, and they display this logic. Try not to use the try, but except. So I'm going to explain this line by lines. So first line is we're going to use the if statement and in statement. There's string, and then we're going to convert type this one. So what it does to check if this data frames object is a panda data frame. If yes, it makes a copy of it and store it in a new variable called df. Why we're doing this? Because it is to keep the original data and change it while we clean and process data frame subject. This is collection of the data groups into the name column. The next is which is the distribute collection of data groups into name columns. And we're using what it does. It is to convert the data into the release year column to text string so we can proceed it easily. This is a method to extract 4 digits years for using from the release year. It can contain text. The next is to keep only row with a valid 4 digits years. But before I explain that, we have to explain this one and that one. We use a string that extract 4 digits to use the regular expressions, which is R and D and digit 4 digits. I'm going to find this 4-digit number in this text, and then the result is stored in a new column called year underscore string. So while using that, sometimes the release years might contain the extract text like to 2020. as Netflix original, but this step pull out just a year part like 2020. So next source code line is this. What it does to keep only rows where year underscore start means the string is not empty with not null. Methods means the not null, and then we're going to copy and put into the data frames object. The data frame object is from the data frames with the columns to copy. Don't forget this one. So I'm going to create a new filter version of the data frames as df with only valid year. So why? I'm going to remove entries where no valid years was identified, ensuring only the meaningful data remains as a data cleaning. We're gonna use the data cleanings. The next line is this one. We're going to convert the extract year string to integer. What it does is changing the year to string, year underscore start date, which is text into the integers and assign to back to this data frames object. Finally is to count movie to show the per year. This is the beautiful code. And what it does is it groups the data by release years and counts the number of entries movie and shows for each year. And it creates a new data frames counts underscore df where each row show a year to total count for that year. So why are we using that? It is to see how many Netflix releases happened in each year, which we can then visualize in charts. We're going to use the charts furthermore in the later in this at the end of this class. The summary, these lines is clean this release year, the columns by extracting the valid years, the filter out invalidate data is the invalid data, convert to text to numbers and summarize the number of release per years ready for visualization. Would you like me to introduce furthermore, simplify or clarify any parts? Please let me know. Then I'm going to next step. So next step is step 3, processing for Spark data frame. Copy this. As you mentioned, the if statement is belong to else or except. So I'm using the if statements and else statements belong to the if statement. From the step 3 to process for Spark data frames for beginner, then using the else statements, there's a import columns and with functions which is they belong to PySpark score statement. What it does in the check if the data frame object is not a pandas data frame, meaning is the Spark data frame. So I'm going to import the columns function from the PySpark, which is used to the refer to columns in Spark operations. Let's break down the line the count is on the score Spark. The first is the filter the valid years. With this filters functions, in the keep row with the 4-digit year and keep only those rows where release year contain exactly 4 digits. Unlike means is applied on regular expressions to match the patterns where the digit 4 means the start of the string followed by 4 digits then end of the string. This is, for example, 2021 past, even 20 or 2021 when Netflix does not. So this was the example. So group data by years is using group by method, and I'm going to count which age group all the entries that have the same release on the by year. That means counts group by year. Third is count entry in each group, the dots with the dot count, the count how many movies and the shows there are for each year. Lastly, we're gonna short the results by year with a dot order by method. The orders it is orders is the results from the earliest year to the last year. After the results is stored in the county Spark, and it is a Spark data frames that shows each year and how many release that happened that years. After the results the store in the county Spark, which is up there, the county Spark in the same values into the pandas data frame called count on the data frames. This is converted to Spark data frame into the pandas data frame called this one. It makes it easier to make plots using pandas and other Python tool. That is what it does. By using the two pandas, the method or functions. The next is S type integer. The convert one. It change the release year columns from the string type or floats into the integer type for proper numerical operations. That is what it does. I'm using that. And the count df is short underscore value is to short the pandas data frames by release year from the earliest to last. I'm going to summarize for beginner gains. This code filters that data to only include the valid for these years. It groups the data by year and counts how many shows we release each year. And after that, it sorts the results in chronological order. And finally, it converts the Spark results of pandas and data frames and sort it for easier learning. Would you like to follow me? Let's go continue. I'm going to explain the step 4 with a code, beautiful code in this time. This is step in plotting the result. From the step 4 plotting the result, I'm going to use this one. It is begins with the subplot. So what it does is to create a new figure and the axis and object for plotting. The size of the plotting is set to 10 inches wide and 5 inches tall using fixed size method or functions. So why are we using that one? It is to set up a canvas where we can draw our chart. To set up a canvas where we can draw our chart, we have to using the second line. What it does is create a line plot. Axis is the release year column, and then the y-axis is the count columns, which is the number of release. After we're using the line of the plots on this axis, and the market is 0 means is to add a small circle at each data point on the line to make them stand out. Why we're using that is to visualize how many movies show were released each year and showing trends over time. But after the line, the 3 things have to explain it all in together. We're using the label, the x-axis, and the y-axis. Today, what we're going to use in that is to set the title for the beautiful visualizations to Netflix release for year. We're going to set title, x label, y label, which is the x-axis and y-axis. And why we're doing that? It is to make the chart understandable and informal. It is informative. With the Python code as an axis grid through what the axis as a grid to the backgrounds of the plot, making it easier to read the position of the data points. And then x-trix, which is the rotates the label on the x-axis, and this year by 45 degrees. Why using that is to prevent the overlapping if there are many years, and to improve the readability. With the tight layout, the functions, it is to adjust the spacing of the plot layout automatically to prevent the label or title from being cut off. That is what it does. And finally, the PRT show that we're going to display the plot window showing the chart to show the Netflix release per year as a set title. So I'm going to summarize all of this. This is a section creates a display of line chart so we can visually see how the numbers of Netflix releases and varies over the years or over the years, making trends easier to better understand. I'm going to run this cell before the step 5. They will be shown this plot in this window. I forgot the Python plot. Have to import. I'm going to import the OS, and then I'm going to import the Python's plot. This Python library. I'm going to run cell again. I will show that one. Okay, finally, the last step is saving the plot. This step is to create a directory in DBFS, Databricks file system, and save the plot as a PNG and make it accessible later via the file store link. Okay, this script is excellent for demonstrating data cleaning, aggregations, and visualization flows with both pandas and Spark. Let me know if you'd like further simplification and or additional explanations. Give me the email. Don't hesitate. So we're going to saving a plot with the local directory. What it does create a string variable local underscore directory is that store the path to the directory where we want to save our plot. Instead of these locations, may I change this one? Like this under the tables folder. What it does is create a string value. This one, we store the path to directories where we want to save our plot. From that locations, we're going to use the special format in Databricks that allow you access files later via a link. That is what it does. So another one is to make a directory. It is to create a folder specific these locations if it doesn't already exist, and it tells us not to give an error if the folder already exists. Of course, that is what it does. The next, the Python code is to join as the combinations, the folder path, local the score data with the file names like this into a full path store in out on the score path. This makes a complete address to where the plot image will be saved. This is what it does. This line, with this line, is saving the current plot, which is called fig PNG image file at the location specified by out on the path. This is to set the resolution to make the image clear, and the other one is it trims any extra white space around the image. Okay, let's go to on top of the cell, clicked run cell. Let's see it works well. So this section is save your plot as an image file, and this Databricks files to work. You can then access this image layer using a link, which is useful for sharing reports for embedding in presentation. Finally, I'm going to display the PNG file inline. Start by run cell. Image not defined. One more thing I'm missing to display this one. I'm going to import from the icon.display. This going to image. I'm going to import image and display too. So finally, I click the run cell. Let's see. It works now. Well done, everyone.